Hello everyone and welcome back to another video from competitive programming. Today we'll be taking a look at the British Informatics Olympiad and we'll be looking at the question 1 taken from the 2017 paper. So let's have a look at the question. Pretty much I'll let you have a quick read of the question, and so pretty much the summary of the question is that we want to combine the initial string of characters which they give, let's say RRG, BRG, BB, and we want to combine that into a single character. And pretty much the rule for combining them is that we take the two adjacent characters, and if those two characters are the same, then the next character which both of them will form will be identical, will be R, not R, but it will be the same as whatever the previous two above ones were. And if they're different, let's say the first one was R and the second one was G, then the next character would be the third character which isn't one of the previous ones. So for example, let's say it was RG, that would produce B as the next character. And if it was B and R, it would produce G as the next character. And as you can see, this pattern basically continues until we've completed the next line. After we do the next line, we repeat the pattern for the next line and so on. So that's pretty much the question, and I'll quickly walk you through my code for it. So I basically have this function, this dictionary I guess, which converts the characters into their numerical formats. Now the reason why I've done this is because 9 times out of 10 it's much easier to work with numbers than it is with letters. Just in these sorts of questions, since with numbers you have all sorts of properties, basic ones would just be like addition, subtraction, which you clearly can't do with letters, but other properties which are more advanced is you can do bit manipulation and things, powerful properties which you won't be able to do with letters. For example, in this question we leverage subtraction. However, towards the end of the video I'll be talking about how we can use the bitwise operation XOR to complete this code in a much neater and more elegant way. But anyways, a bit more on that later. Let's just have a quick look at the question now, as a solution now. So pretty much we have this function f, and it takes in two numbers. If the two numbers are equal, it returns the number, just as the problem statement requires. And if the two numbers are different, then it returns 6 minus n1 plus n2. So, since the numbers which we're dealing with are 1, 2, and 3, their sum will be 6. If we take any 1, 2, and 3, it will be 6, right? Hence, if we want the number which isn't 1 or 2, for example, let's say we have 1 and 2, and we want the third. So then, if we want the one which isn't the third, then we'll do 6 minus the sum of 1 and 2. Since 1 and 2, 6 minus that will produce 3. If we have 1 and 3, it will produce 2, and if we have 2 and 1, if we have 3 and 2, it will produce 1. So this is quite a neat way to do it, rather than having several if loops, because otherwise if we didn't have this, we'd have to do if the number is 1 and the second number is 2, or the first number is 2 and the second number is 1, and return 3, and then we would need to go through all possible combinations of them. That would just get very messy, but this one line of code just does it very quickly. Turns 6 minus n1 plus n2. Okay, and that's pretty much just the heart of the logic, since this function will convert any two numbers into their next number. So all we need to do is do that for every single number inside one line of the code, and then we do that for the next line, and so on and so forth. So we take the input of RGB, and then after that we convert each element into its numerical format inside the array. And then we iterate through while the length of the array is greater than 1. We continue applying this function. And this list comprehension pretty much generates the next line in the array. So for I in range len r minus 1, iterates through each element until the second last element. The reason why it's the second last is because if we had it iterated till the last, it will produce an index out of bound error, since we're accessing the ith plus 1 index, which would be out of bound if we iterate till the last one. and this generates the next line, and we repeat this until the length of the array is just 1, so it's just one character long. And then after that, we've basically finished, and we convert the numerical format back into the other format which we have. So now let's just take some inputs and see if our programming will work. So this basically outputs B, which is indeed the correct answer. And if we test on this input as well, it outputs R, which is also the correct answer. So that is pretty much it with regards to this code. Now, this code was clearly the simpler approach, but there is also a much more sophisticated approach, let's say, which is much more elegant. So if you're interested in that, I'd highly recommend you stick around, and I'll just quickly go through that code on the whiteboard, the pseudocode for that. So pretty much, I'll just be walking through the alternative Excel code now, which is an optional way to solve the problem, pretty much. So just consider the binary representation of 1, 2, and 3. So 1 would be 0, 1, 2 would be 1, 0, and 3 would be 1, 1, right? So if you're familiar with the XOR operation, if not, don't worry, I'll just quickly tell you what it is. So how the XOR operation works is it takes 2 bits. If the 2 bits are 0 and 0, it will output 0. If the 2 bits are 0 and 1, it will output 1. If the 2 bits are 1 and 0, it will output 1. And if the 2 bits are 1 and 1, it will output 0. So it's basically the same as the OR operation, like either the first one or the second one, with the exception that if both bits are set, i.e. both bits are 1, it will not output 1. So you might be thinking, well, if there's AND and OR operations, why would it ever need XOR? But XOR is actually very useful for modeling certain situations. For example, let's say if students were to either take like French or German, but you can't take both of them, then that would be modeled with something like XOR, right? You have to take one of them. That's the only way you can output a 1, i.e. valid combination. But you can't take both. So situations like that can be modeled with XOR. And XOR can actually be used in our code right here as well. So these are basically the 3 numbers, 1, 2, and 3. And if we consider 1 XOR 3, so 0, 1 XOR 1. So 1 and 1, both of them will basically produce 0, right? Because as I just said, 1 and 1 produces 0. So the rightmost bit will basically be 0. And 0 and 1, over here and here, that will produce 1. So then our output will be 1, 0, which, behold, is 2. 1 and 0 is corresponding to 2. So if we just run this code, we'll pretty much output 2. This symbol is basically XOR in Python, N1 XOR N2. And now if we change it for 2, it will also work, because 2 XOR 3 will basically be 1. And now you might be thinking, well, how does this relate back to our question? This can basically be like an alternative for this. So if we were to write, instead of 6 minus N1 plus N2, if we could instead write N1 XOR N2, it would basically still work. But now, how would we represent this one with XOR? In this case, we just return N1, which is perfectly fine. Or if we're just being like really fancy, what we could do is the XOR sum of this 3 times. This is a bit unnecessary, but just for like your understanding, how this works is we'll basically XOR this 3 times. So if we XOR it just twice, then any number XOR itself will basically just be 0. Like, I'll leave you to figure out why, but the reason is fairly straightforward. For example, like 1, 0, and 1, 0. Any bit which is 0, 2 zeros will basically give 0, and 2 1s will give 0 as well. And if 2 numbers are the same, every bit will be identical, hence every bit will give 0. So this will basically give 0. But then if we add a third XOR, it will basically be 0 XOR the number itself, which will give 2. So then an alternative way would just be N1 XOR N1 XOR N1. If we were to convert this in XOR, this is completely unnecessary, but just in case you guys are curious, how we would do so. But this is an alternative way to do this. However, the 6 minus and 1 plus n2 approach is also perfectly fine. Just in case, it's worth remembering this for future questions. So, yeah, that is pretty much it for this question. And I hope you enjoyed making this video. If you did, please be sure to leave a like and subscribe, and I hope to see you in another video. Thank you very much for watching. Bye.